We're live. Okay, so today we're back to doing what we call, so they're called radicals. Square roots, or any kind of roots, or any kind of root is called a radical. That's just the math term, it's a radical. That symbol is called a radical symbol. Okay, that's all there is to it. It's just a math term. I don't care if you remember the math word, but I'm going to give you the vocabulary anyway. Okay. Now there is a rule, and I don't even know if it's a good rule, but it's a rule for sure. And the rule is that you cannot have a square root or any root. You cannot have any root in the denominator. It's kind of a silly rule. And when you go to college, some teachers in college don't care if you leave it like this, and some teachers do. So I'm going to teach you how to fix it, okay? So again, I'll say this carefully. When you go to college, some professors, some college teachers don't care if you leave it in this answer. They're fine. Some teachers follow this rule, okay? So what we're going to do is we're going to fix it. We're going to fix the problem with the rule of 1. It's called the rule of 1 because I'm going to multiply both of these equations by the square root of 3 over the square root of 3. Because square root of 3 over square root of 3 is 1. That's called the rule of 1. That is the number 1. And what it does is it creates a perfect square in the denominator, okay? It creates a perfect square right there. And of course, if it's a perfect square, you can take the square root of it. And when you take the square root of it, it's no longer a square root, right? So I would rewrite this equation now as, on the top, on the numerator, 2 square roots of 3. In the denominator, you get the square root of 9. And the reason we did this is because the square root of 9 is just 3. So I can take the square root of 9, it becomes a whole number, not a square root number. And I get 2 square roots of 3 over 3. Okay, now, don't be tempted. That is the answer. That is the answer. Don't be tempted to divide this because you see, that is not really a 3. Square root of 3 is not a 3. So don't divide 3 into 3 because that is not a 3. That's a 1.73. That is the answer. 2 square roots of 3 over 3. So what do? These two have the exact same value. The only difference is these two have the exact same value. The only difference is we have rationalized the denominator, meaning there is no longer a root in the bottom. No root in the bottom, okay? All right, so we used to say fix the problem with the problem. I'm going to state it a little bit differently today. I'm going to say let's make a perfect square or cube or fourth, okay? Okay, so we're going to try and make a perfect square or a cube or fourth. That's our goal today, okay? Well, when I take a look at example 2, I'm going to rewrite it as the square root of 3 over the square root of 5 because it's really dividing both of them, okay? So I'm square rooting both of them. And really what I want to do is make that into a 25. I want to make that into a 25, right? Because the square root of 25 is 5. So I multiply both top and bottom by the square root of 5, square root of 5, right? Remember doing this last year? Yeah. We say fix the problem with the problem, right? There's the rule of 2. The rule of 1, I said that wrong. I will get the square root of 15 over the square root of 25, right? Which is actually 5. I don't know what she is. Which is the square root of 15 over 5. Do not divide the 15 and the 5. Don't do that because the square root of 15 is this number. Don't divide those. Don't divide those at all because that's a whole number 5 and that is not a 15. That is not a 15. That's a 3.87 blah 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 blah, okay? All right, now, example 3 is actually really easy. Don't let it trick you. It's as simple as this. They're both perfect squares. So don't do anything fancy. Just recognize that that is a 6 over 7. I just took the square root of 36 and the square root of 49, okay? Okay, now, example 4. What I need to do is I need to make this number here into the cube root of 27. I need to make that number into a cube root of 27. I need to make the bottom into a cube root of 27 because that's a perfect cube root. Does that make sense? Or here's another way to think of it. I've got 1 3. Now if I had 2 more 3s, I'd make a 3 cubed. I don't know whichever way you want to do it, but let me show you one way to do this. Okay, this is one way to do it. That'll make 3 to the 3rd, wouldn't it? Now if you don't like that way, raise your hand. Okay? So then if you don't like that way, multiply by cube root of 9, cube root of 9. Is that easier? Because you'll wind up with, I'll finish this one and then I'll do it another way. You'll wind up with, on the bottom, the cube root of 3 cubed, which is just 3. You guys don't like it that way, do you?
No.
Okay, so let's not do it that way. All right, that's fine. We'll do it the other way. I just try and show a couple of ways for you guys to do it because some people like that way. Julian, do you like the way I just showed or not?
No.
No, okay, let's change it. Cube root of 9, right? Just make it cube root of 9 because I know the 9 times the 3, so we're going to cube root of 9, cube root of 9. So in the denominator, we're going to get a cube root of 27 over the cube root of 18. You okay with that? See, that's the way you guys like it. That's fine. That's fine. And then the cube root of 27 is a 3, right? Over the cube root of 18. Don't divide the 3 into the 18. I know I'm making a sound like a broken record, but really the cube root of 18 is this number. That is not an 18. That is not an 18. That's the cube root of 18. Don't try and divide those. Am I making sense why you don't divide those? That is not an 18, right? Now, is there a root in the bottom? Yes, no. Is there a root in the bottom? No, it's gone. That's our goal, is to rationalize the denominator. No roots in the bottom, okay? Okay, then how about example 5? How are you guys going to tackle 5? It's a 4th root. There she is. It's a 4th root. So look at your, up there, your perfect force. What can you make this number into? Okay, so you're ahead of me. You want to make it into an 81 because you want to multiply by 27, right? So Julian's saying, let's multiply by the 4th root of 27. Okay. Now, I'm going to go back and once again show it to you slightly different. And I'll erase it. That's a cube, 3 cubed. Because if I do 3 times 3 cubed is 3 to the 4th. I don't know if this helps you. You need to see it eventually. So then I have a 4th root of 3 to the 4th, right?
Yeah.
I think that's easier.
Wait, but does that count?
Absolutely, because he's canceling what you're left with.
Oh my god! What?
So much. I think that's the easier way to look at it. Okay, but you guys like doing it this way?
I don't know.
Okay.
I don't
Anyway.
know.
Anyway. So
If you can, it'd be so much more.
How did, like, what do you do with the top?
I have to do that too. So yeah,
You did it.
that way. Yeah. So I would do this.
Bro, you're so
let me make it 3 to the 3rd. 3 to the 3rd. I would just multiply this as the 4th root of 5 times 3 to the 3rd.
Is that a good answer?
Well, it's 27 times 5, right? I mean, I would take this in the test. That'd be 3.
Okay.
Because it's going to be a 3.
You would take that on a
That's going to be the 4th root of 3 to the 4th,
Yeah, where did you do that? If you take that on a test.
which is 3, right?
Yeah.
Charles, you see why I do it that way? To me, it's
A little
easier.
bit, yeah.
To me, it's easier to do it that way.
That's funky.
I know. Use that brain. Okay. So then, I'm not concerned with which method you like to do it. I'm going to go ahead then and rewrite this as the 4th root of 5 times 27. I don't know what that is. I don't know. 5 times 27, 135. over the 4th root of 81. So you chose to make the 4th root of 81 because you knew that was a perfect fourth, right? You knew that was a perfect fourth. 4th root of 81 is just plain old 3, right? There you go. Okay. Okay, when you're ready, give me thumbs up. Now, example 6. I'm just going to make it easier to start off with. You mind if I just make it easier? If I just reduce it, it reduces to, I just did one thing. 15 tenths, 3 halves. You okay with that? 15 tenths are reduced as a fraction. Divided both by 5. Okay, so then what I have is square root of 3, square root of 2, right? What am I going to do? What do I need to do? Right, I'll make a perfect square. I'll make the square root of 4, right? So I'll get the square root of 6 over the square root of 4, right? Which is the square root of 6 over 2. Again, don't divide those. You can't really divide those because that is not a 6. That is not a 6. Don't divide those. That's not a 6. Okay? All right? So, example 7. Charles, I have 2 5s here. If I could put in a third 5, I'd have 3 5s. That's the way I think of it.
Yeah.
Okay? Or, what do you guys want to multiply by? What do you want to multiply by? That's 5 squared, right? How many 5s do I need? That's 5 squared. I need 3. Okay, what up here is a perfect cube that I can make it into? Look in the red. What number can I make it into? 125, right? So if I multiply by the cube root of 5, I'll make a perfect cube, right? I'll have in the numerator cube root of 15, and the denominator I'll have cube root of 125, which is a perfect cube root, which I know is 5. And in the numerator, I've got the cube root of 15. Don't divide those because that's not really a 5 at all. That is not a 5. Cube root of 15 is, I don't know. Hold on. Cube root of 15 is some ugly number. Oh, I'll forget it. You know what it is. Okay, now, how about 8?
We've got 2 3s. We need 2 more.
Charles, yes. Yes. Now that's the way I do the way Charles does. I got 2 3s. I need 2 more to make 4 3s. But Dulce said 9 because she saw straight to 81, right? So either way, 4th root of 9. Whoops. 4th root of 9 is going to make a 4th root of 81, which is one of our numbers in orange, right? 4th root of 81. And then in the numerator, I'll have the 4th root of 36. There is no 4th root of 36, so don't even bother. It's just going to be the 4th root of 36 over 3. Okay? Last one. What do you think? What should I multiply by? 4th root of 4. So what I see is 2 2s, 2 more 2s. Charles?
Yep.
I got 2 2s, I got 2 more 2s, right? Which makes 4 2s, right? Dulce saw that square root of 16, or 4th root of 16, right, Dulce? Which is a perfect, they're both correct. Both methods work. For me, I don't really care which method you use as long as you can do it. So I'm going to get the 4th root of 20 over the 4th root of 16. 4th root of 16 is 2, right? So then I get a 4th root of 20 over 2. All right, what do you think?
I think
So you got a math here that's going to be very similar to this kind of thing, and I've got an easy little homework assignment to follow.